Alright, this is hopefully the last video that I will have. It have learning target 6 and 7 on it. Alright, so I can explain the nature of colligative properties. So first off, colligative properties, um, they depend on the number of particles. Alright, not what they are. Okay, so if we have NaCl, when it's dissolved in water, it's going to break down into sodium ions and chlorine ions. All right, so it's going to break down into multiple particles. Okay, if I had sodium oxide, all right, it's going to break down into 2 sodium atoms plus an oxygen atom. Okay, so if you look at these two, the sodium oxide is going to have the bigger amount. Okay, this one, there is a total of 3 particles on this side, only 2 particles for the top one. So this one, sodium oxide, is going to have more colligative properties, okay? Vapor pressure lowering is the first one. Since the particles, they are going to be able to hold that vapor pressure, so the gas being turned into a vapor, it's going to hold it in the liquid more often, okay? The pressure right above that liquid is not going to be as high, okay, because those particles aren't able to escape. Since the vapor pressure is lowering, boiling point is going to go up. It is going to increase. And the reason why is normally you have vapor pressure here, okay? You have boiling point here. You heat this up so it rises, it rises, it rises. This is what's called temperature. All right? Normally if we had pure water, all right, this is going to go from, maybe it goes from 20 degrees all the way up to 100. Right? Well, what happens is vapor pressure, if we lower it, okay, this is our vapor pressure. We've lowered it because we've added solvent to it. Our boiling point is going to become higher, okay, because it's going to take more heat for it to reach that boiling point, because vapor pressure and boiling point have to equal each other, okay, or atmospheric pressure. Once they equal each other, then it starts to boil. But with vapor pressure being lower, it's going to take more energy, more heat to get there if you have particles in there, okay? So if it is a pure solvent, okay, it is going to have a lower boiling point, okay? If it is a solution, it is going to have a higher boiling point, all right? Freezing point depression is it's going to cause those particles to not interact and not to form a frozen molecule. Okay, it will cause it, they won't be able to get as close to each other because those solute particles are going to be in the way. Right, that's how ice, putting salt on ice works. Okay, the salt starts interacting, it starts dissolving with that solid ice, turns it back into liquid because it's lowering that freezing point. Lowers to a point where it's going to turn it into water, so therefore the world will no longer be icy. Okay, so those are colligative properties. The more solute you have in all of those solutions, the more effective vapor pressure lowering. The lower the vapor pressure could go, the higher the boiling point could increase. Okay, lower the freezing point of depression, lowering the freezing point. Okay, the last part is the 3 types. So we have solutions. Okay, solutions, they're really small particles, cannot see through the particles. Okay, they're very small. All right. All right. So in terms of, I can't read what that says. So in terms of particle size, so they are the smallest. Okay. Oops. They are the smallest, and they have no Tyndall effect. All right, a beam of light is just going to go right through because the particles are so small. Okay, and really the only way to separate these would be through like distillation, okay? Or some other mechanism where you'd have to boil water or maybe centrifuge, things like that, okay? Colloids are a little bit different, okay? They are that medium-sized particle. We still probably cannot see them to our eyes, so we're going to have what's called that Tyndall effect. It's going to cause a beam of light to hit those particles and you're actually going to be able to see it. Okay, so we would be able to do the Tyndall effect to those different liquids to see, is it a colloid? Are there pieces in it? Okay, are other particles in it, or is a solution when it's really, really small? Okay, again, we cannot filter it um, or let it settle, so we'd have to do some form of separation, such as distillation, centrifuging, something like that. Okay, the last one is suspension, so we can actually see usually the particles. Okay, the biggest thing is we can use a filter to separate them, bigger particles. All right, we can usually see them. Okay, filtering is a big thing. They also have the Tyndall effect. Okay, so if you have questions, please let me know. Shoot me an email or come in and see me tomorrow. But those are all of the learning targets. So let me know if you have questions. Use your book. It will be very helpful for you as well. All right.